There are various methods of estimation. Let us discuss them one by one. I will also use an example. How long will it take to travel by road from Toronto, Canada to Manhattan in New York City, United States? First method, rough order of magnitude or ROM method, sometimes also called a ballpark estimate. This is the method used in the very early stages of a project, usually at the start of initiating when the project idea is being generated. This estimate is based on the overall previous experience and perception. The estimate is very quick but also very rough, typically in the range of -25% to +75%. So for our example, I'll say my ROM estimate is 10 hours, which means that it can take anywhere from 7.5 hours, which is -25%, to 17.5 hours, which is +75%. As long as the travel takes between these two limits, my ROM estimate will be considered a good estimate. The ROM estimate is commonly expressed as a range and not as a single number. That means I will say my ROM estimate is between 7.5 and 17.5 hours. Now, why such a wide estimate? It is because I have not considered anything besides my journal experience, perception, and intuition. If I have made that journey in the past or I know of someone who has, then I won't give a ROM estimate. Why go for a rough estimate when a relatively accurate estimate can be done? So in this case, I will go with the analogous estimate, also called top-down estimate. This is the second method we will discuss here. In this method, historical data from a previous similar project is used to estimate the new project. Information from the previous project that is helpful is how long it took, how much work was there, how many resources, complexity, size, stakeholders, and other factors are considered. The estimate is usually an overall estimate. So for our example, the last time I traveled from Toronto to New York was a night drive, and I was traveling alone, driving a sedan, and it took me 8 hours. This time I have to travel with my family, and we have one toddler and one infant, and we will be traveling during the daytime in a minivan. Therefore, overall, I expect that it will take longer than 8 hours, and I come up with 10 hours estimate. Considering that there is more traffic during daytime, so slower travel, with young children frequent stops are needed, so slower travel, and so on. The third method is the parametric estimating. In this method, some calculations are done using historical data, statistical data, as well as variable data. In our example, some factual information is available that Manhattan, New York City is about 800 kilometers from Toronto, which is about 500 miles. So from my previous experience, when traveling long distance, I travel at an average speed of 100 kilometers per hour, which is like 60 miles per hour. So by dividing work to be done, travel in this case, by the expected productivity, speed, I see that it will take about 8 hours. Now this estimate is more accurate than the analogous estimate, but takes a bit more time since all that high-level information has to be determined. The general formula used for parametric estimating is the amount of work divided by productivity. I have not considered several pieces of information. Exactly from where in Toronto I am leaving, right from downtown or the west end or the east end. What time I will be leaving, 4 p.m. or 4 a.m. What time I'll cross the international border, during rush hour or off time. How many stops I'll be making on the way and for how long each stop will be. Missing all those details mean that my estimate is not the most accurate. And the most accurate method is the bottom-up estimate. This is the fourth method we will discuss. In this method, the work is broken down into smaller components, and then each component is estimated and the cost is then aggregated to get an estimate for the work package and for the project. And it can be cost or time both. Work packages were decomposed into activities, so estimate can be done for each activity. The work parameters, the risks and challenges, the variables, all can be determined here with a high level of confidence. So the estimate will be highly accurate. It will take time to do a bottom-up estimate, so it is a time-consuming and expensive method, but it is a highly accurate method. In our example, all those questions will be explored, leaving from where and when the international border will be crossed and where stops will be made. It will require time to establish all that information. Say, leaving from the downtown core at 4 p.m. will add much more time than leaving the same place 4 a.m. in the morning when there are only few cars on the road. Traveling with young children, the plan can be a pit stop every 2 hours for half an hour. So that adds up 1.5 hours to the trip. Now to the fifth and last method. This method is used when there is a lot of uncertainty and risk. This method is called 3-point estimation method. The other methods provide 1-point estimate, but this method comes up with 3 estimates. These are called optimistic estimate, pessimistic estimate, and most likely estimate. An optimistic estimate is based on the best outcome. PMBOK calls it best case scenario, where things go in work's favor. And based on that, we can calculate how long will it take to do the work. The pessimistic estimate is based on the worst case scenario, or when things are falling apart, not going in favor of the work. So the estimate based on that, how long will it take to do the work? And most likely is what is expected to be the situation looking at a combination of factors. For example, which resources will likely be working, what the weather is expected to be. These are just some of the questions that can be asked. This is a kind of situation where some good things will happen and some bad things will happen. In other words, the most likely estimate will fall somewhere in between the optimistic and the pessimistic estimate. So how can the project team use these 3 estimates to come up with a single estimate? There are 2 common methods used for this purpose. These are called triangular distribution and beta distribution. The formula for triangular distribution is optimistic plus most likely plus pessimistic, and then divide the sum by 3. Why 3? Because 3 estimates were added, so it will give an average of the 3 estimates. The formula for beta distribution is optimistic plus 4 times most likely plus pessimistic, and divide the sum by 6. In this case, 6 estimates were added, an optimistic, a pessimistic, and 4 most likely estimates. So it is a weighted average. When to use which one depends on the data that is being considered. The beta distribution is based on the beta curve, also called the normal curve. When there is enough data available to pass the normality test, beta distribution can be used. But if there are only a few or maybe 3 estimates, then triangular distribution will be used. For example, I got an estimate for how long it will take to get from Toronto to New York from 3 different people. I can use triangular distribution, take the average of their estimate. But what if I got historical data from 40, 50 or more people? I will use the beta distribution. Here is an example I use in the class. I ask participants, how long is their commute from home to work? And then select one of them who said about 45 minutes. Next, I ask, what is the fastest they have made from home to work in the last 12 months? The answer is 30 minutes. And how many times this has happened? The answer is 2-3 times. Then I ask, what is the longest it took them to get to work from their home? The answer is 90 minutes. And how often that happened? 2 to 3 times. So it means that most of the time they made it from home to work in around 45 minutes. This is the most likely estimate, and this is the reason it is given 4 times more value, because chances of hitting this estimate are much higher than the optimistic or pessimistic one. So to wrap up, I presented 5 different methods of estimation. Rough order of magnitude is the roughest and quickest method, while bottom-up estimating is the most time-taking but highly accurate method. 3-point estimating is used when uncertainty is high, while analogous is used when a previous similar example is available. And the parametric estimate is used when historical as well as variable data is available and there is a statistical relationship that exists between them.